I'm self-taught when it comes to metalwork, so as you can imagine I had to learn a range of new skills when I turned to making a steam engine. I searched on the internet until I found a suitable set of plans. The first part I made was the base, using a 4mm piece of brass plate. The holes were cut using my milling machine. Next were the 3 bearings to support the crankshaft. To obtain accurate concentricity between upper and lower parts, they were first soldered together, then drilled to accommodate the crankshaft. After this, the 2 parts were heated and separated again. And here I'm showing the bearings after they've been temporarily attached to the base. The con rods were turned to size on the lathe, then features such as the slot for attachment to the piston guides were cut using the mill. The cylinders were turned up using a 4-jaw chuck on the lathe. This involved a bit of fiddling around with the dial gauge in order to centre each cylinder for boring. The entire upper works of the engine are supported on a 3mm brass plate, suitably drilled for holes to accommodate the conrod glands, valves and support columns. This was made straightforward using the digital readout on the mill to locate the exact spot for each feature. The pistons were turned to a snug but sliding fit in the cylinders, with piston rings being made to fit the slots using some nylon stock. The piston rods were made of 4mm silver steel, cut to length and threaded to accommodate the guides. Below the pistons we can see the valve rods and eccentrics. Again, these were turned on the 4-jaw chuck and making adjustments of the part using the dial indicator. The piston guide was a bit finicky due to its small size. Here we can see one of the guides attached to the end of the piston rod, and it's about 1 centimetre in width. Inlet and exhaust manifolds were made from brass tubing and flanges turned on the lathe. I had to do this twice because 4 screw holes are accessible, but not 6. Think about it. There were quite a few brass screws used in the assembly, or were they bolts? Okay, so now we seem to have all the parts made. There are support stands, valve guides, valve sleeves and the guide support. The cylinders and valves are supported by 6 brass rods screwed into the base. Their precise length is critical to a good result. Now we can see how this is coming together. The valve guide support slides over the support columns. As can be seen, there are a couple of extra holes in the top of the guides. This was the result of a mistake I made in the original alignment of the holes to attach them under the support. I had to correct the mistake by a slight adjustment of their location. At this stage we also have the crankshaft and conrods fitted. This is the underside of the support plate that sits on the support columns and holds the cylinder block in place. You can see the steel cylinders through the holes for the piston rod gland nuts. The cylinder is attached with the brass screws shown. Also at the top you can see the angle bracket that holds the upper end of the piston rod guides. The piston rods need to be sealed off in the gland nut to a smooth running fit using a short length of graphite infused yarn packed into the space around the rod. Fabrication of the gland nuts proved to be a steep learning curve for me, and I had to make a second set as the first attempt resulted in non-concentric holes between the nut and the lower piston cover. Here we can see the cylinder block which has been drilled and tapped for the piston caps, and also the exhaust outlets. The holes for the valve sleeves can also be seen on either end of the cylinder block. After the initial testing and tweaking the valve timing, I made a proper mounting plinth and inlet pipe arrangement for the engine.